Thank you. Thank you. Good afternoon. I flew down from Boston this morning, and we had a chatty pilot, which for me, you'll learn in the next couple of minutes how awesome this was. So the pilot was talking about exactly what flight level we were going to fly at, that we were choosing that flight level because of turbulence. Here's where we're going to have turbulence. Here was where we weren't going to have turbulence. And it got me really pumped up, and in the next couple of minutes, we're going to talk to you about why that was so great. Now, I know you can think that's a little weird, but stay with me. Okay. So let's start first with a short intro. Okay, so let's talk about the world of weather. Weather is a daily habit, and for consumers, the average consumer of an Apple iPhone is checking the weather 21 times per month. Okay? There are lots of consumers that are checking the weather 50, 60, 80 times per month. There are lots of people that are obsessed. When you have consumers interacting with you every day, it gives you a lot of data to work with. There is almost no business that I'm aware of where weather isn't affecting those businesses. Some of that is pretty obvious. The one I'd call out in particular is if any of you who know people that are growers in any part of the world, weather has such a huge impact on their livelihood, on what they're doing on a day-to-day basis, what they can do, can't do for their farm. Weather is affecting virtually all these businesses. One factoid, if you look at the picture about the trains, is once the temperature of the rail on a railroad is 115 degrees, you have to slow down the train. Okay? So you have to really understand the weather interaction with virtually every one of these businesses. And you don't have to go very many months in the US to see pictures like this where people really get into trouble. Lives are at stake. This is a big impact area. So we have impact in terms of consumers. We have impacts in terms of virtually every branch of government and business, and lives are at stake. So let's try to put some color on that notion of mapping the atmosphere. One example I give you is there's a pressure sensor inside your smartphone. So if we have your permission to access your smartphone for that pressure data, we're now collecting smartphone pressure data from 30 million phones. to understand the barometric pressure around the world. Another example I give you is we're supporting around 50,000 commercial flights a day, so we're getting data from those 50,000 flights, and especially what's going on above the surface of the Earth actually has more to do with what's happening to all the weather we're living in than what's going on at the surface. The next comment I'd make is on location data. When you're understanding where consumers are moving and exactly what location they are, you're understanding the context of those consumers, you'll understand that it's not like the actual weather that's going to change consumer behavior. It's how that reflects the context of that consumer, exactly where they live. 65 degrees in San Diego is not the same thing as 65 degrees in Chicago. It's a whole different universe. On the right side, we talked about 150 forecast models. We're bringing in 150 versions of forecast models each and every forecast cycle to try to create the most accurate forecast. Roughly 20% of those, for example, are coming from NOAA. This is one example of, these are just personal weather stations that citizens have put in their backyard, okay? Grown from roughly 20,000 to 200,000 in the last couple of years. Roughly 2/3 of these are based outside the US, often in countries where there are very few government reporting stations. So having kind of 200,000 extra data points just from personal weather stations is a good example of the Internet of Things, how we're accessing it. The second example I'll give you is planes. Now, when I was getting giddy like a schoolgirl about the 20,000 foot flight level and the captain talking about turbulence, here's why I was giddy. Okay? We've got software running on the bus of the plane. It's objectively measuring the g-forces of the plane so that when that plane is encountering turbulence, a message is being sent down to our operations center. We can update the forecast for that airspace and say, okay, now there's turbulence in that airspace. We also know every other plane that's going to fly through that airspace. We can send a message to that plane that says, yo, don't fly there, or yo, decrease your flight level by 4,000 feet, or go around it, or whatever. But essentially, we've connected the dots between essentially a sensor on a plane coming down and allowing us to inform every other plane that's going to fly through that airspace to watch out and take evasive action. Okay? So this is kind of the notion of the Internet of Things, not just data from a sensor, but actually doing a round trip from the plane and then back around to all the other planes driving through the airspace. We will be doing the same thing with cars. Okay? So now you're starting to really do that at scale. So, big data is a buzzword, and I typically hate buzzwords. The one thing I'll say about the weather world is, trust me, we were doing big data before the term ever came into being. It's been one of the most compute-intensive applications since the 50s. Okay? Here's what we have done differently in terms of big data. 2 years ago, we were forecasting for 2 million locations on the globe. Today, we forecast for 2.2 billion individual locations around the globe. Okay? So pretty soon, you're getting up to real numbers there. Right? We're updating forecasts every 15 minutes. So every 15 minutes, we're updating a forecast for up to 2.2 billion locations. And we're doing it on demand. So if you have a smartphone and you're making a request for the forecast either to weather.com mobile app or to Apple natively or to Google or whomever, we're taking that long. We're going and asking the system that's based in the cloud, give me the freshest forecast in real time for that precise location, whatever the most recent forecast was, using the most recent updated forecast information. We're doing that in under 100 milliseconds. Okay? So for tens of millions of consumers on the native applications and for hundreds of millions of consumers coming into, for example, the Apple native app, we're serving every forecast request we're getting on the fly in under 100 milliseconds. Okay? That's what we mean by doing it on demand. So when you do the math, it adds up to a few forecast calls per day. Okay? We're averaging around 15 billion. For context, this is about 4x the scale that Google deals with in terms of searches, in terms of calls per day. So we're clearly dealing with kind of massive amounts of requests for data at very specific points in time from very specific latitude, longitude locations. Okay? So that's what when I talk about big data at scale, this is one example of what we're talking about. This is a lot of forecasts. On a peak day, we do around 26 billion. You clearly could not do 15 billion to 26 billion if you weren't doing this in the cloud. Now, as we've essentially gone to expand the amount of data by 1,000-fold in the last couple of years, what's been really interesting to me is how it's actually changed the opportunities that we're dealing with, and I'm going to try to give you some insight into that now. So let's talk about alerts. A year or so ago, I was in Chicago. It's downtown Chicago. It's 5 p.m. Tornado sirens are going off. Now, I may not be the brightest bulb under the tree, but I think I understand what you're supposed to do when the tornado sirens go off. You're not supposed to be walking down the streets of Chicago. You're supposed to be taking shelter, right? I'm taking shelter, but I'm watching outside out of this window hundreds and hundreds of people that were not taking any action. They were just walking down like it's a car horn blaring. Okay? Now let's take a different angle. We provide alerts, for example, for hail, and the alert comes across to your cell phone like this. In the next 30 minutes, there will be hail big enough to break your windshield at your precise location. Move your car. When we do that, 52% of people move their car. Okay? Now, if you think about it, 52% that's a big number, right? Because forget about whether you've got insurance or not. You don't want to have to go through the hassle of a broken windshield, having to go to the shop, replace it, all that stuff. So that's one really good example of when you have a really precise alert, precise in time, precise about kind of how bad the problem is going to be, and precise about your location, people will take action. Okay? You'll see there's one of the kiosks out in the open area here. There's a kiosk that just focuses on alerts. That essentially is the approach that, as IBM, that we are offering to a number of different organizations to try to help be much more precise about alerts, because it's the 52% people doing something that we care about. Let's give a second example. Funny thing, when the temperature is below 32, when the temperature is above 90, bad things happen to car batteries. Okay? So if you're a car battery manufacturer and you want to run ads, you actually don't really want to be running an ad when it's 60 degrees Fahrenheit. You want to be running the ad in those locations where it's below 32 or above 90, okay? So what we do at the weather company is we actually have a whole series of weather triggers that are based on the particular product that's being advertised, knowing exactly how demand is affected by weather, location by location by location around the US and in fact around the world. When you on your smartphone are coming in and asking for a piece of content, we decide in the moment exactly which ad to serve you. Okay? In that case, we're giving ourselves 200 milliseconds to decide which ad to show you. And that ad is going to be one kind of ad if the weather conditions are favorable, let's say, for battery sales, and we're going to show a different kind of ad if it's unfavorable, which we'll be advertising some other product but not batteries. Okay, and that's a simple example, but trust me, on days when it's a bad hair day, if you're Pantene or you're some other shampoo manufacturer, when you're advertising on a bad hair day, trust me, your sales go up, okay? Now, this is all about being precise in triggering ads for a specific consumer behavior for a specific location based on a specific weather location. Here's a different example about being precise, and I'm going to start with the picture on the right. For any of you who live in the Carolinas, and I think it was certainly a national story, I think it was mid-January this year, the forecast was for 18 inches of rain. Okay? Now, this was an example where 2 days before, many of the major entities that produce forecasts for this country, including NOAA, had the forecast completely right. Completely right. Okay? What I think many of us, including our company, failed to do is we forgot to be really precise in painting the picture of, so how bad is 18 inches of rain really, okay? So we're talking about 18 inches of rain. We're not showing the picture on the right-hand side. The right-hand side is what 18 inches of rain really looks like. That's what it's going to feel like if you're driving, right? Being really precise in painting the picture of what the weather will how it will really impact you is another dimension of being precise. In the example on the left, what I'm going to show is if you only have a few reporting locations for trying to estimate how much rain is falling, it's really hard to be precise about where the biggest areas of flooding are occurring. But if you start getting much more precise about the density of your network, now we understand much more precisely where the most severe instances of flooding are occurring, and we know if you're in the public safety realm where you should be thinking about closing roads. Okay, so this is another example where precision is really driving better action and saving lives. We have to, I've been in this business a long time. There are enough people that, God bless them, think they're in an SUV, they think they can get through 18 or 24 inches of rain. We have to help protect them from themselves because they keep thinking they can do this. I don't know about you, I'm tired of looking at video shots like this. Now let's talk about analytics for a bit. So, what we've really found, and we serve around 90% of the airlines in the US as clients. We serve around 25% of the top 100 airlines outside the US as clients. And giving them the weather information really isn't enough. What they really are caring about is they're trying to run an airline, right? They're trying to get passengers from place A to place B safely. They're trying to make sure they have the right amount of fuel on board. They're trying to figure out, are they going to have delays either at the departure or the destination airport? So let's talk about what we're doing for those airlines. We're using predictive analytics to figure out, based on the weather, based on which direction the wind is, based on what the runway configurations are going to be for each of the airports in the US, what is the airport capacity for each hour of the day? From 3 to 4, how many planes can take off and land at JFK, at O'Hare, at Midway, et cetera. We're then also understanding, based on that, what we know about the flight schedule, and based on what flight tracking is occurring, exactly how many planes are going to want to be landing at O'Hare or JFK during that hour. Now, for all of you scoring at home, when the green line is really high, this is not good. This is not good. This is saying, uh-oh, we now have about 20 more flights that want to use O'Hare in that hour than O'Hare has the capacity to manage. Okay? Now, if I'm in an airline, there are a couple of things I can do here. A, I sure better put more fuel on board for every plane that's flying to O'Hare because they're going to be holding. B, I sure as hell better put more fuel on board because there's going to be more taxi time once I land because this airport is going to be congested. Okay? I may decide to delay my departure. I may decide to cancel a flight. Let's talk about cancellations for a minute. If you look at cancellations in the US in the last couple of years, any of you who travel a lot have noticed more flights get canceled earlier than ever before. Okay? Now, despite that, what's happened to total cancellations? Total cancels have gone down in the US, despite more and more and more airlines canceling earlier and earlier. And it's because when they cancel early, they're able to return to regular operations faster. Less of their operation gets screwed up in the end. And in the end, they can kind of return, get everybody back to normal faster. So all these kind of analytics tools to use to say, based on the weather, what are the decisions I have to make ahead of time to try to make this the best experience overall for my passengers. This is a great example in real life of what we're doing in the airline space. Second example is in utilities. This is, again, predictive load forecast. The utility doesn't really care what the weather is going to be. They want to know how much power they have to deliver to the grid, right? The answer they're looking for is how much load. So what we now do using analytics is take our weather forecast and translate it into a projected demand for load, okay? It's not, it's machine learning based approaches to providing the answers that people really need. Next example I'll give you is, let's talk about probabilistic forecasting. Let's talk about the example on the left. Many government entities kind of take a typical cone of uncertainty for what is the average error for a forecast for a tropical cyclone or a hurricane. And I'm going to plop that on whatever I think the path of the storm is going to be, and I'll give it a range of uncertainty. That's how people have traditionally done it. What we're doing on the right-hand side is completely different. We're essentially taking all of those forecast models that we're using, the 151 forecast models, and we're essentially establishing what is the probability of landfall along this section of the coast. Maybe it's 2% for this section of the coast, 3% for this section, 5% for this section, etc. So we're essentially giving a probabilistic forecast for landfall everywhere along the coast for every tropical storm and hurricane in the Atlantic and Pacific. It's really bringing precise data to use for essentially for people that are in the evacuation decision business to decide when should I evacuate, what locations do I have to be worried about. It's a huge advance for what probabilistic forecasting will mean for all of us. So now let's talk about making decisions earlier. Here's one example. This is a project we're doing with the Chinese government. We're using weather data, but one of the most important issues that the Chinese are wrestling with is air quality in lots of cities, including Beijing. So this is an example where we're blending weather data and other atmospheric and physical chemistry models so that we can help predict up to 7 days in advance by day how bad is the air quality going to be so that the Chinese can then decide, do I start enforcing alternate day traffic for drivers? Do I start shutting down manufacturing plants? Do I start shutting down coal plants? There are a lot of decisions that the Chinese can choose to make when the air quality is going to be bad. This is one really good example in my mind of helping governments make a better decision based on precise weather. Second example is with smarter cities. And in this case, what I'd argue is we're getting very precise about traffic flows, very precise about weather accumulations, for example, ice and snow and rain, down to the half-kilometer basis. We can enable governments to do much more precise estimates of what's the areas of impact. And this is my favorite story to end with. So for people like me that come from the Northeast, we don't tend to think that a half-inch of snow is all that bad. If you're from Minneapolis, you would conclude a half-inch of snow it just means it's going to be bad sledding, right? If you're in Atlanta, this is what happens when you have a half-inch of snow. Now, this was a couple of years ago. This is January. The forecast, just like the Carolinas, was awesome. 2 days ahead of time. NOAA had this nailed, okay? Everybody still went to school that day. Every person went to work that day. And then at noon, the city decided they would close all the schools, and 1 million text messages went out all at the same time that said, we're closing the schools, come get your kids, okay? These are all the people trying to go get their kids. Now, they're not doing very well at getting their kids, but that's what they're trying to do. And I use this as the poster child of, I think, the biggest challenge for all of us in this room, which is it's not just about precise data. It's actually not just about analytics being applied to the data, but it's ultimately, yes, weather is an uncertain business. You don't always get the forecast right, but we get it right way more often than not. The challenge for all of us is now to figure out how to become bold enough to make a decision ahead of time so that next time we don't send these kids to school, we send the workers home, we close the roads so people can clear the roads. We kind of make a decision in advance so we can avoid stuff like this, okay? And so what I would ask you is, these are my 5 takeaways. I would simply say, we are, at least for myself, I feel like I'm very lucky to be alive today where we have the chance to make this much improvement in people's lives. Thank you very much.